Welcome back to another episode of Learning Integration. This is the basics of the power rule, and here we have basically the power rule when integrating. You got a function f(x), it equals x to the power of n, and when you integrate it, or when you find the integral of this function, you use a capital F, and you grab the x, you add 1 to the power, and you divide it by the new power. And then you add a constant, or add c, to show that you're adding a number that could or could not have been there before. Okay, so I'll just start with an example to help with that. Let's say we have f(x), we'll say it equals x. That was something simple. Okay, use a capital F to show that we're finding the integral. We use the operator for the integral, this fancy stretched out looking s and dx on either side of the function, which in this case is x. This shows that we've the integral of one side and the integral of the other. The capital Fx shows that the integral of fx, and this funny looking s and dx shows that is the integral of x. Now we will do this and, well, essentially use the power rule to find out what the integral is. Okay, so the power rule says we need to add 1 to the power and divide it by the new power, and then add c. So x, add 1 to the power. So x by itself has already got a power of 1. So if we're adding 1 to the power, it would be 1 plus 1. And that would be over 1 plus 1, because that is the new power. The old power was just 1. The new power is 1 plus 1. And then we add c. You always add c, because when you derive it, if you were to derive this, you would get rid of the c. If you were to derive anything with a constant, you would get rid of the constant. So if you integrate it, you don't know if there was a constant there to begin with, so you just put c there anyway. And if you don't put c, that could be that's a problem, because if there was a constant, say if you were deriving this and there was a constant and you went to integrate it and you didn't put the constant back, then it'd be a different function. It'd have a different answer. But anyway, we'll simplify this. 1 plus 1, x to the power of 2, over 1 plus 1, 2 plus c. And that there is the integral of this up here. I'll do another example. With example 2. Say we have a function, it equals x squared plus 3. The integral, capital F, equals a funny looking s, bracket, we'll insert the function, put dx on the end. Using the rule of sums, we split the integral using the addition sign. We find the integral of each side separately. Plus, and find the integral of the other side. So integral of x to the power of 2. Just use the power rule, so we just add 1 to the power and divide by the new power. And then we add the derivative, the integral of 3. Because there is no x on this, we just add an x, because by having it, you use the rule, I think it's the rule of constants, where if you have a constant and you you find the integral of a constant, you just add an x and then a plus c. I'll explain this right now. When you essentially think of it as having the x multiplied by 1, because that's everything's multiplied by 1 if it's there. Well, not everything. Anyway, 3 is multiplied by 1. The 1 is invisible. 1 also equals anything to the power of 0. Let's say x to the power of 0. Therefore, if we were to add 1 to that, then we would end up with x to the power of 1, because x to the power of 0 plus 1 is x to the power of 1. So that's essentially sort of what we've done here. We've just 3, and when we integrate it, we add 1 to the power of x to the power of 0, which just when you integrate a constant like 3, 4, 7, 8, 9, you just add an x to it. And the reason I didn't add a plus c to this side when I integrated and to this side is because you only need 1. The idea is you can have several of them in here, but you just add c on the end. You can add c here, like this would be right too. If I was to, I'll simplify this, x to the power of 3 on 3. I could have plus c, and then I could add 3x plus, we'll use d. I could do that. But because we don't know the values of these, when you add them together, rewrite this, x to the power of 3 over 3 plus 3x, we could have plus h. And h would signify c plus d. Like, it's just a constant. We don't know what it is. We don't know if it's real. We don't know if it's fake. But you don't have to write this. This would be also correct. But you'd have to add those two together and come up with another letter. But this is also correct. This is what you would most likely find. You usually, people tend to integrate whatever needs to be integrated, and then they'll just add c on the end. I hope I didn't just confuse you, but that's generally the idea. So you don't have to do this or this. You could just do this and add c on the end. So the final derivative will look like the final integral. Keep saying derivative. Would be x over 3, x to the power of 3 over 3 plus 3x plus c. And that is the integral of this function up here. Okay. So if we do another example, one final example. So we have a function 2x to the power of 3 plus 3x. Integrate one side, we get capital F. We integrate the other side, 2x to the power of 3 plus 3x dx. We split this up using the plus sign, and we get the integral of 2x to the power of 3 dx plus the integral of 3x dx. There's also another rule, I think another rule of constants where if you have, see how we've got 2 times x to the power of 3, that's a constant times x to the power of 3. And the rule, there's like 2 rules of constants, and the second one says that we can bring the 2 in front. And it will look like this. Because we don't want this 2 affecting when we integrate, when we find the integral of x to the power of 3. So we bring the constant out the front. And when we find the integral of this, we multiply the 2 back in later. So let's find the integral. The integral of x to the power of 3, that would be add 1 to the power and then divide by the new power. X to the power of 3 plus 1 over 3 plus 1. Then we add that to the integral of 3x. We'd bring the 3 at the front. I should have done that up here. Bring the 3 at the front and just find the integral of x. So we have 3 multiplied by the integral of x. Just like before, add 1 to the power, divide by the new power, plus c. Therefore, it would look like 2 multiplied by x to the power of 4 on 4 plus 3 multiplied by x to the power of 2 on 2 plus c. Now we can simplify this over here. We can get rid of the 2 and we can take 2 off the bottom and make it a 2. Therefore, it would be x on 4, x to the power of 4 on 2 plus 3x to the power of 2 on 2 plus c. And that there would be your integral of this function up here. I hope that helped. I hope it didn't confuse you even more if you are struggling on this. But as I said, I hope this helped. Thanks for watching.